Okay, here's our video on imaginary numbers, part one. And imaginary numbers, actually, they shouldn't even be called imaginary numbers because they aren't fake. They are real in a sense, but they're not part of the real number system that you learned all the way in elementary school and junior high and high school. Imaginary numbers, where you learned perhaps your second year of high school in Algebra 2. But imaginary numbers have a useful purpose, right? They're used in electricity, they're used in quadratic equations. So in electricity, by the way, they don't use the letter I, which we're going to be using today. So you're going to see this letter I for imaginary numbers. But in electricity, when they're using electrical engineers, they'll use J. Well, not that script J, but something like that. Something like that, the J. All right. And they're not a new concept, right? The idea of imaginary numbers goes back at least to the 1500s, of maybe credited to a man named Cardano in Italy. All right. Anyway, let's get a clear page going here. When you see them with quadratic equations, it's if the quadratic is, if the parabola, you see this parabola over here, if the parabola does not cross the x-axis, then you know this will be an imaginary number. For this video, we won't talk about the purposes and the usefulness of imaginary numbers. We'll just talk about what they are. So let's just start off. Let's make sure we have our pen going. We're going to start with red. Why not? So, when we do square roots, when we do the square root of, let's say, 25, well, we know the square root of 25 is plus minus 5 because negative 5 times negative 5 is 25, and positive 5 times positive 5 is 25. So we know the square root of 25 is this. But when we're doing the square root of negative 25, well, this is imaginary. It doesn't fit within the real world system because there's no numbers with the same signs, same number that will give us this. So this is imaginary right here. So let's look at imaginary numbers. And imaginary numbers are also complex numbers, which we'll talk about, not in this video, but we'll talk about them in the next video. So let's look. Let's clear this out first of all. Let's get a clear page. So when we're looking at imaginary numbers, if I say the square root of negative 1, we're going to call that I. We got to get used to this symbol here, I. And if I had the square root of negative 25, which we had before, well, we'll have to split it. We'll have to split it. Stick with me for a minute. So just remember that the square root of negative 1 is I. So with the square root of 25, we can split it up. We can have it as, we're going to put the square root of 25 times the square root of negative 1. We're splitting it apart. We know that 25 times negative 1 is negative 25. All right. Now, since we must make a little arrow here. So if I split it apart, we know that the square root of 25 is 5. And you remember the square root of negative 1 is I. So there it is. There's our answer, 5I. Well, let's do another one so you can get it. What if I had the square root of negative 8? What do you think you can do that based on what I've done before? Well, first we want to split it up. Split it. So if you want to pause the tape. So let's look at the square root of 8. Now remember, with square roots in general, we can split this up, right? We can have the square root of 4, and we can also have the square root of 2. That gives us 8. But we also need the square root of negative 1. And the square root of 4 we know is 2. So we have that, but we can't get the square root of 2. That's irrational in itself. So let's put a little arrow here. So what we're left with is we have 2, and the square root of negative 1 we said is I, and we have the square root of 2, which we couldn't break down. I'll do a couple more so you see it, how you get used to this. Just remember the square root of negative 1 is I. Keep that in mind. So let's clear this out. Let's do another one. What if I gave you, and you should use red still, what if I gave you the square root of negative 18? We know it's imaginary, How would you break that down? How would you split it? How would you split it? Why don't you pause the tape and give it a try? So with the square root of negative 18, right, we can have the square root of 9. I mean, we could just have the square root of 9 without that negative sign, right? And we can also have the square root of 2, right? Square root of 2. And then we can have the square root of negative 1, all in this zone here. So the square root of 9 we know is 3. The square root of 2 we're not going to have. We don't know what the square root of 2 is. It doesn't give us a perfect square. It's irrational. And the square root of negative 1 is, you guessed it, I. So what would be our answer? 3i square root of 2. That's our answer for that. All right. So if you're getting used to it, maybe, let's do another one over here. Change the color. What do you think the square root of negative 36 would be? Try that one. Pause the tape. So we have, let's see what we have in the box here. Well, we have the square root of 6, right? The square root of 6 times the square root of 6. And then we have the square negative 1. Or is there something else we can use? Always try to see if you can get a constant out of it. Well, this we won't get a constant, but what if we did the square root of 9 times the square root of 4 times the square root of negative 1? Square root of 9 times 4 is 36, right? So the square root of 9 is 3. The square root of 4 is 2. And then we have the square root of negative 1 is I. So this would be 6i. So remember, always try to get something with a perfect square. That's why we didn't use the 6 times 6 one. Didn't use this one. But we used this one. 9 times 4 is 36. And negative 1 gave us negative 36. All right, let's clear that out. Now we can also add. We're going to add, and we can also add and subtract. So we can add and subtract imaginary numbers, right? So what if I gave you 5i plus 2i? What would that equal? Well, they have like terms. Just remember, if I did 5x plus 3x, well, that's 8x. If we did 5x plus 2x, well, that's 7x. In the same way here, they have like terms. They have the imaginary number I. So this would be 7i. Right? And if you remember how we got 5i, remember that 5i is also the square root of negative 25. And how is that, right? Because we said the square root of negative 25 is we're going to use the square is 5 times negative 1. The square root of 25 is 5. And then we have negative 1. So this would be I. And there's the 5. 5i. Try to add this one. What if I gave you negative 25 plus square root of negative 25 plus square root of negative 4? What would that give you? Oh, and by the way, going back here, I forgot the 2. It's 25. The square root of 25, not the square root of 5. The square root of 25 gives us the 5. So here, the square root of negative 25, we already know that answer, right? We already know that that's 5i. But what is the square root of negative 4? How do we break that down? Well, 4 times the square root of negative 1, which will be 2i, which is 7i. All right, I think you get it. What if we had it? What if it was 10i minus 3i? What's that answer? 7i again. We have a 7i pattern going on here. And one more, if we had 15i minus 10i, well, it is 5i. So adding is pretty easy. What about multiplying now? If we want to multiply, well, let's say we had 5i times 2i. Well, remember, if we had, let's say, 5x times 2x, this will give us 10x squared. 5i and 2i will give us something similar. It will be 10i squared. 10i squared. Now, it's important to know now that a little bit about I and I squared. So let me clear this out. All right. Here's a chart I'm going to give you. In the next video, I'll go over the chart detailed. But for now, if you just can memorize this, if we have I, and we have I to the 0 power. Well, anything to the 0 power is 1. Keep that in mind. But we have I to the first power, which is really just saying I, because we don't usually use the exponent or the index 1. Even with, exponents, when we say 3x, we don't say 3x to the first power. We know the 1 is there. So I to the first power is I. I to the second power is negative 1. I to the third power is negative I. And I to the fourth power is 1. So we have to try to keep this in mind what this is all about. By the way, we can also see that I is the square root of negative 1, which we said earlier. Now, after the fourth, it's going to repeat the cycle. So here, when we said 5i times 2i, we got 10i squared. And what is I squared? Negative 1. So this is going to be 10 times negative 1. And the answer will be negative 10. Because remember, I squared is negative 1. Now, if you can remember this, and this is how some students remember it, with the 1, 2, 3, and the 4. Think of an I. Think of 1. Think of I. And think of 1. Now you're saying, what is this all about? Well, if you can remember I1, and then think of it with the positive sandwiching up the negative, this may help you. It's helped a lot of students in the past. Maybe it's not going to help you, but that's just a mnemonic device, so a little way you can remember it. We'll keep that in mind. So, and I said it repeats. So if you had I to the fifth power, well, I to the fifth power, it will repeat itself, and it'll be I. I'll use another color. And again, next video, we're going to explain more of this. So again, if we repeated, this will be I to the fifth. That'll be I to the sixth. Put in our dots. I to the seventh. I to the eighth, and so on. And then it'll repeat again. I to the ninth. I to the 10th. I to the 11th. I to the 12th. And so on. Now, you don't have to do this. There's a way you can get this by dividing everything by 4. For example, if you had I to the fifth power, if you do 5 divided by 4, you're really concerned about what the remainder would be. So 4 goes into 5 once. You don't care about that, but the remainder is 1, and that's what you're looking for, the remainder. So you take the remainder and put it with the I. I to the first, if you look over here, is I. I. Let me show you again. We'll keep doing more. Change the color. If I said I to the 10th, we're going to do 10 divided by 4. 4 goes into 10 twice. We don't care about that. We just care about the remainder. The remainder would be 2. So this would be I to the second power. I to the second power is negative 1. Hey, there's that I to the 10th. Right on the same line. Let's make that chart again. Clear this out. So again, remember we're saying, we already know that I to the 0 power is 1. We'll just keep that over there because anything to the 0 is 1. So we have I to the first, I to the second, I to the third, I to the fourth. And so remember, I told you, if you can remember, I won. You screamed I won twice, with the positive sandwiching the negatives. Right? So what should this one be? I positive, right? 1, 1, but negative. I, but negative. And 1, positive. How would you do I to the 15th? So again, it's 15 divided by 4. That goes 3 times, but you don't care about that. How much is remaining? 3. So you're going to say I to the third power. And what's I to the third? It's negative I. So with that, you can do any one. See if you can do this. What's I to the 138th power? Try that. Pause the tape if you need it. I'll change the color. Give you time to pause the tape. So what is the first thing you should do here? Right? It's 138 divided by 4. It's always divided by 4. And that'll be 34. The remainder, that's what we're looking for, remainder 2. So it's I to the second power. And what's I to the second power? Negative 1. So I to the 138th power will be negative 1. Right, so that's just part 1 of imaginary numbers. Part 2, we'll talk more about complex numbers and more about this imaginary chart here.